Welcome back to another exciting episode on this channel. Today's topic is truly fascinating because I'm introducing a brand new mathematical function called the mu function. But before we get started, if you ever have doubts or questions, make sure to join our Discord server. The link is in the description. Now let's dive into it. The mu function is a special type of summation, which means it adds up an infinite series of numbers following a specific pattern. Mathematically, the mu function of a number, let's call it r, is found by adding up fractions, where each fraction has a special type of factorial in the denominator. But before we go further, let's first understand what this special factorial really means. You've probably heard of a regular factorial before. It's when you take a number and multiply it by all the whole numbers that come before it. For example, 5 factorial, written as 5 times 4 times 3 times 2 times 1, gives us 120. But in the mu function, we use a different kind of factorial. We call it the rth factorial, and it follows a unique pattern. Let's break it down. 1. First factorial, r equals 1. This is the normal factorial you already know. You take a number, multiply it by the number right before it, then the number before that, all the way down to 1. 2. Second factorial, r equals 2. This is called the double factorial. Instead of multiplying every number, we skip every other one. For example, if we start with 6, we multiply 6 by 4, then by 2, and we stop there. 3. Third factorial, r equals 3. This is the triple factorial. Here we multiply a number, then skip 2, multiply the next, skip 2 more, and continue the pattern. 4. General pattern. In general, if we have r8th factorial, we multiply the starting number, then jump by r each time until we get as close to 1 as possible. Now that we understand how these factorials work, let's see what happens when we apply them to the mu function. If we choose r to be 1, meaning we use the normal factorial, the mu function becomes a famous mathematical series. It starts with 1 divided by 0 factorial, plus 1 divided by 1 factorial, plus 1 divided by 2 factorial, and so on, forever. This particular series is very well known. It's actually the definition of Euler's number, which is about 2.718. So in this case, the mu function gives us Euler's number. Now, if we switch to the second factorial, meaning we skip every other number, we get a different sum. This time, the mu function adds up fractions where each denominator is a double factorial. Surprisingly, this series also gives a specific number, which is approximately 3.059. If we continue this process, increasing r each time, the mu function keeps converging to a definite value. But what happens if we push this to the extreme? If we let r grow indefinitely, meaning we use a factorial that skips more and more numbers, the mu function no longer settles on a finite value. Instead, it diverges, meaning it grows without bound. And here's something really interesting. When r is infinite, the mu function is directly connected to the Riemann Zeta function. Specifically, the mu function at infinity equals 1 plus the zeta function evaluated at 1. Since we know that the zeta function at 1 diverges, this tells us that the mu function also diverges in this case. This is an amazing connection between two mathematical ideas, the mu function and the zeta function. Now let's take this a step further. What if we extend the mu function beyond regular numbers? What if we use something called a virtual unit? In the virtual numbers system, there's a special symbol, let's call it j, which is defined as the natural logarithm of -1. This brings up a very intriguing question. If we calculate the mu function using this virtual unit, will it converge or will it diverge? That's a deep topic, and in my next video I'll explore it in detail by introducing the idea of a virtual factorial. So, what do you think about the mu function? Do you find these mathematical connections surprising? Let me know your thoughts in the comments. And don't forget to like this video, subscribe to the channel, join our Discord server for more discussions. See you in the next video.